Have you ever wondered what would happen if Earth was as dense as a black hole? Imagine for a moment the world as we know it, packed into an object so dense that not even light can escape its gravitational pull. Black holes, these enigmatic entities, have long been a source of fascination and curiosity. They twist and contort the very fabric of space and time, creating phenomena that defy our everyday understanding. Ready to dive into the depths of this cosmic conundrum? Let's begin. Before we delve into the dense matter, let's first understand what a black hole is. Picture an object with a gravitational pull so strong that nothing, not even light, can escape its grasp. This is the essence of a black hole. Born from the remains of a star, when a massive star exhausts its nuclear fuel, it collapses under its own gravity and forms a singularity, an infinitely small and dense point in space. Now, let's talk about the formation of a black hole. The life of a star is a delicate balance of forces. The outward push of energy from nuclear fusion in the star's core is counteracted by the inward pull of gravity due to the star's mass. When the fuel runs out, gravity wins, and the star collapses. If the star is large enough, this collapse leads to a supernova explosion, leaving behind a core so dense that it warps spacetime, creating a black hole. Characteristics of a black hole are as fascinating as its formation. At the center of a black hole lies the singularity, where matter is crushed to infinite density. The laws of physics as we know them cease to function, and spacetime curves infinitely. Surrounding this singularity is the event horizon, a boundary beyond which nothing can escape the black hole's gravitational pull. Now let's focus on the incredible density of a black hole. Imagine all of Earth's mass compressed into a sphere with a diameter of just over ½ an inch. That's how dense a black hole is. To put it another way, a sugar cube-sized amount of black hole material would weigh as much as Mount Everest. That's an astronomical amount of mass, packed into an incredibly small space. So with this understanding of a black hole's density, imagine if Earth shared the same characteristic. Stay tuned as we dive into this cosmic thought experiment in the next segment. If Earth were as dense as a black hole, it would be a dramatically different place. Now, let's dive into the dense depths of this cosmic curiosity. Imagine our home planet, Earth, suddenly compacted to the point where it matches the density of a black hole. Our beloved blue sphere is now a tiny point, smaller than a grain of sand, yet still containing the same mass. Black holes are incredibly dense, so dense in fact that they warp the fabric of space and time itself. By becoming this dense, Earth's gravity would undergo an extreme makeover. It would be so intense that nothing, not even light, could escape its gravitational pull. You might think that this would mean the end of life as we know it. However, the reality is a bit more complex. If you were standing on the surface of this ultra-dense Earth, you wouldn't be squished into a pancake. Instead, you'd experience gravity as you do now, since gravity depends on mass and distance. And those have not changed. But what about the Earth's size? Well, here's where things get really interesting. The ultra-dense Earth would be unimaginably small. As mentioned, it would be less than a grain of sand, a cosmic speck floating in the vastness of space. All of Earth's landmarks, continents, oceans and life forms would be compressed into this tiny point, yet the planet's overall mass would remain the same. We wouldn't have room to exist as we do now, and our world would be fundamentally changed. However, the interesting thing is, we wouldn't necessarily be sucked into the black hole. Instead, we would be in a state of free fall, perpetually falling towards the center, but never reaching it, due to the intense gravitational time dilation. In essence, Earth would become a singularity, a point in space where density becomes infinite, and our understanding of physics breaks down. But the effects wouldn't stop there. The transformation of Earth into a black hole-like entity would have far-reaching implications not just for us, but for the entire universe. Stay tuned to discover the cosmic consequences of this incredible thought experiment. The extreme density of a black hole would have far-reaching effects beyond Earth. To begin to grasp the magnitude of such an event, we need to imagine the solar system as a grand cosmic ballet, with each planet gracefully dancing in its orbit. The sun, the star of the show, holds everything together with its gravitational pull. But what would happen if one of the dancers suddenly gained an immense amount of mass, becoming as dense as a black hole? The gravitational balance of our solar system would be thrown into chaos. The pull from Earth, now a black hole, would dramatically increase, disrupting the orbits of nearby planets. The moon, once our friendly celestial companion, would be the first to be sucked into the abyss, followed by the inner planets, Mercury, Venus, and even Mars. The sun, though massive, would also feel this new gravitational pull. It could even start to wobble, causing other planets to adjust their dance steps, changing the rhythm of the entire solar system. Even faraway outer planets like Jupiter and Saturn could have their orbits perturbed, potentially leading to cosmic collisions. The asteroid belt, a region of space between Mars and Jupiter filled with millions of rocks, would be stirred like a cosmic soup. This could unleash a barrage of asteroids hurtling in all directions, posing a threat to any planet in their path. And it wouldn't just be our solar system that's affected. The increased gravity could reach out into the galaxy, drawing in nearby stars and their planetary systems, causing further celestial chaos. But it's not all destruction and chaos. The birth of a black hole also means the birth of a cosmic laboratory, a place where the laws of physics as we know them break down and where new, unexpected phenomena might be observed. So, while the transformation of Earth into a black hole would undoubtedly be a cataclysmic event, it would also provide a unique window into the fascinating and extreme world of black holes. Indeed, the consequences would be astronomical. As intriguing as this scenario is, it remains firmly in the realm of the theoretical. Let's delve into why an Earth as dense as a black hole scenario is impossible in reality. To comprehend this, we need to understand the basic laws of physics and the nature of matter. Matter, as we know it, exists in different states: solid, liquid, gas, and plasma. Each state has its own distinct properties, and they're all governed by the laws of physics that have been constant since the dawn of the universe. Now consider the phenomenal density of a black hole. It's so dense that it warps the fabric of space-time itself, creating a gravitational pull so strong that not even light can escape. For Earth to reach such a density, it would have to undergo a process called gravitational collapse, where its matter compresses to an almost infinitesimal point, known as a singularity. But here's the catch. Earth, composed primarily of rock and metal, simply doesn't have enough mass to trigger a gravitational collapse. This is a process reserved for celestial bodies of a far grander scale, such as massive stars at the end of their life cycles. Moreover, the Pauli exclusion principle, a fundamental law of quantum mechanics, prevents particles of the same kind from occupying the same quantum state simultaneously. In simpler terms, there's a limit to how much you can compress matter before quantum forces kick in and resist further compression. So even if we could somehow artificially increase Earth's mass to prompt a gravitational collapse, the laws of quantum mechanics would intervene, preventing Earth from reaching the density of a black hole. In essence, the laws of physics and the nature of matter conspire to make an Earth as dense as a black hole scenario an impossibility in our reality. These laws, which govern everything from the tiniest particles to the grandest galaxies, ensure the stability of the universe as we know it. So, while we can ponder and explore such scenarios, we can rest assured Earth will remain as it is. Our journey into this cosmic thought experiment has been a fascinating one. We've traversed the borderline of reality and fiction, exploring what might occur if our home planet, Earth, was as dense as a black hole. To recap, we first grappled with the enigma of black holes, celestial bodies with a gravitational pull so strong that not even light can escape. We then toyed with the concept of the Earth possessing this same unfathomable density. In this scenario, Earth would shrink to the size of a marble, yet its mass would remain unchanged. This would cause catastrophic cosmic consequences, with the fabric of space-time around Earth warping to the extreme, leading to a deadly gravitational pull. We've also ventured into theoretical possibilities and impossible realities. Here we examined how the laws of physics as we know them would be stretched to their limits and even broken. Time, space, and life as we know it would drastically change, leading us to question our understanding of the universe. In this thought experiment, we've peeked into a world of paradoxes and enigmas, challenging our perception of reality. This exploration of a cosmic what-if scenario is a testament to human curiosity and our endless quest for knowledge. So next time you look up at the night sky, remember, there's always more to ponder in the vast expanse of the cosmos.